Ever feel like your brain is just juggling way too much information?
Oh, absolutely. All the time.
Yeah, stuff coming at you from all sides, and you need to figure things out quickly, like what's the next step at work, or what did that text really mean?
Or even just what's for dinner.
Exactly. And that process, that constant making sense of things, that's basically thinking, right?
That's it. We're always taking in information, planning, interpreting, trying to predict what's next. And a huge part of that, right in the middle, is decision making.
Okay.
It's fundamentally about seeing the different options you have and then picking one based on, your values, your goals, what feels right.
And it's tied up with problem solving too, I guess.
Very closely. Often, making a choice is the way you solve a problem. You choose a path forward.
Okay, so let's dig into this a bit because sometimes making a decision feels instant, like, boom, I know I like that song.
Right.
But other times it's a real slog, like figuring out a complex issue.
A mental workout, yeah.
Yeah. And that difference, that's really what we're diving into today, isn't it? This idea of the dual process model of thinking.
Exactly. The idea that we have these two sort of main ways our brain tackles decisions. Researchers often call them system one and system two.
System one and system two. So
So system one is like your brain's autopilot. It's fast, automatic, feels effortless. Think about seeing surprise on someone's face.
yeah, you just know it.
You just know it. You don't sit there analyzing eyebrow angles. It's instant recognition. That's system one.
It's that gut feeling.
Precisely. That immediate sense you get about something. But then you have those other times.
Yeah, like that riddle. If a lily pad doubles in size every day
Yeah.
and covers the whole pond in 30 days,
Mm.
when does it cover half the pond?
Right. For most people, that doesn't just pop into your head.
Definitely not for me.
That's a system two job. It needs
Yeah.
that slower, deliberate, step-by-step thinking. So today, we're really going to unpack these two systems, how they work, when we use them, and importantly, what it all means for how you process information and make choices every day.
Great. Let's start with the fast one then. System one, what's going on there?
Okay, so system one, it's running automatically, super quickly, usually with very little effort. You might not even be aware it's happening.
Like background processing?
Exactly. And it relies heavily on intuition and these things called heuristics.
Heuristics, those are the mental shortcuts, right?
That's them. Think of them as rules of thumb your brain uses to make quick judgments. They help you focus on maybe one key aspect of a complex problem and kind of ignore the rest.
Which sounds efficient.
It is very efficient for everyday stuff.
Hmm.
But there's a catch.
Ah, knew there would be.
These shortcuts, because they ignore some information, can lead to errors, especially if the assumptions your brain makes based on the shortcut don't quite match the reality of the situation.
Right, and you mentioned it creates this feeling of certainty.
Yeah, that's characteristic. Because it feels so effortless and quick, the answer system one spits out often comes with this strong sense of, yep, that's definitely right, even if it's not.
Which makes you less likely to question it, I suppose.
Exactly. So when are we most likely to fall back on this system one thinking?
Good question. When does it tend to dominate?
Well, research, like work by Gilbert and Gill, suggests it's more likely when our cognitive load is high.
Meaning when we're thinking about a lot of stuff at once.
Precisely. Or doing multiple tasks, or when we're under time pressure. Need a decision now.
Okay, so if I'm juggling emails, a deadline, and trying to remember what I need from the store.
Your brain's more likely to default to system one shortcuts. Your mental bandwidth is stretched, so it goes for the low effort option.
Makes sense.
And just to quickly list its key features, system one is very context dependent, deals with everyday stuff, gives you those initial impressions or inclinations. It's not really logic based, so prone to errors. And like we said, automatic, fast, minimal effort.
Got it. Fast, intuitive, sometimes wrong, but feels right. Okay, so what about the other side? System two, the slow thinker.
Right. System two. This is your more conscious, deliberate, rational thinking. It takes effort.
How does it work differently?
Instead of jumping to a conclusion, system two involves a much more careful process. You might consider different interpretations of a situation first.
Okay.
Then you gradually weigh the evidence, eliminate possibilities, and work your way towards a solution. It's more step by step.
So much more analytical, like really chewing on the problem.
Exactly. You're thinking about what's happening, why it's happening, maybe what's likely to come next, even how you could influence things.
And you said it doesn't give you that same feeling of certainty.
Generally, no. Because you're aware of the effort involved, the steps you're taking, you're often more conscious of alternatives or uncertainties. It feels less absolute than a system one hunch.
It sounds more reliable, but maybe more tiring.
Definitely more tiring. It requires significant mental energy, and that's, a finite resource. You can't be in System 2 mode all day long.
You'd be exhausted.
Yeah.
So what are its main characteristics then?
System 2 tends to operate more in the abstract realm. It handles conscious reasoning, strives for logic and reliability, but the trade-off is that it's slow and requires that effort.
Okay.
And another really key thing is its ability to transfer learning. It can take information or a solution from one situation and apply it to a new, different one.
So that's how we learn from experience and apply lessons more broadly.
That's largely System 2 at work. Now, critically, these two systems aren't usually working in total isolation.
Okay, how do they interact?
Often, System 1 fires off first with a quick take, an initial conclusion. Then, System 2 might kick in to review and analyze that first response.
So System 2 is like the fact checker for System 1.
Ideally, yes. But here's a crucial point, something Wesson highlighted way back in '68. Because System 1 is so fast and automatic,
Yeah.
its activation can actually interfere with System 2.
Interfere? How?
That initial gut feeling or intuitive jump can be so strong that it biases System 2's analysis, or sometimes even prevents us from properly engaging System 2 at all. We just stick with the first thought.
Wow, okay, so the fast system can actually trip up the slower, more logical one.
It definitely can. And that leads us nicely into talking about some evidence for this, like the Watson selection task. You mentioned that earlier.
Right, the card task. How's that show the two systems?
It's a fantastic illustration. So in the classic abstract version, people see 4 cards. Maybe they show, say, an 8, a 3, a red color, and a brown color.
Okay.
And they get a rule, something like, if a card has an even number on one side, then its opposite side is red. The job is to figure out which card or cards you absolutely must turn over to see if the rule is true or false.
Right, I think I remember this. And the common answer, the instinctive one, is to pick the 8 and the red card.
That's exactly it. Most people go for those two. It just feels right because those are the things mentioned in the rule. Even number and red.
But you said that's wrong.
It is wrong. And this mistake shows what Watson called matching bias. In abstract problems like this, we tend to just latch onto the words in the rule.
Okay, so why is 8 and red wrong? Let's break it down.
Okay. Turning over the 8 is correct. You need to check if the other side is not red. If it's, say, blue, the rule is immediately broken.
Makes sense.
But turning over the red card, it tells you nothing useful about this rule. The rule says even implies red. It doesn't say red implies even. Finding an odd number on the back of the red card doesn't violate the rule.
The rule only goes one way. Okay, I see that now. So which one should we turn over?
You need the 8, for the reason we said,
Yeah.
and you need the brown card.
The brown one, why?
Because if that brown card have an even number on the other side, that would violate the rule. The rule says all even numbers must have red on the back.
Gotcha. And the 3 doesn't matter because the rule only talks about even numbers.
Exactly. It's irrelevant.
That really highlights how System 1 just grabs the obvious stuff, even in red, and ignores the actual logic.
Precisely. And Evans and Wason found that people who picked 8 and red often couldn't really explain their reasoning logically. They just felt right.
Supporting the idea it's an automatic, non-conscious System 1 response.
Yes. And fascinatingly, Wason also found that even if you train people on the logic, they often make the same mistake again if you give them a similar abstract problem with different items.
Wow, so that bias is really sticky.
It seems to be. You gave another example, didn't you? The names and subjects one.
Oh, yeah. The rule was if there's a male's name on one side, then there's an IB subject on the other. Card showed John, Mary, chemistry, football.
And again, the common mistake is John and chemistry matching the rule's terms.
Right, but the correct answer is
John, to check for a non-IB subject, and football, to check if there's a male name on the other side, which would break the rule. Again, System 1 overrides the logic for many people.
it's like our brains are pattern matching the words, not the logical structure. But this changes when the problem is less abstract, right? More real world.
Massively. Griggs and Cox did a version with a rule like, if a person is drinking beer, then that person must be over 18.
Okay, that feels more familiar.
Exactly. And the cards might show drinking beer, drinking Coke, 25 years old, 16 years old.
Right, and here people are much better at it.
Way better. Around 75% correctly identify. You need to check the person drinking beer to see their age, and the person who is 16 years old to see what they're drinking.
That's a huge jump in accuracy. Why is the concrete version so much easier?
The thinking is that System 1 is actually much better suited to these kinds of situations. We have real-world experience and social rules baked in around things like drinking age.
So our intuition, our system one, has learned the relevant connections.
Exactly. It triggers a more accurate, intuitive response because it's grounded in experience, not just abstract symbols. Abstract logic puzzles tend to trip up System 1, but familiar, concrete scenarios let it use its strengths.
That's a really clear demonstration. Okay, so we have this behavioral evidence. What about biological evidence? Is there proof in the brain?
Yes, there is some compelling evidence from fMRI studies. Goel and his colleagues, back in 2000, did research that looked directly at brain activity during these kinds of tasks.
What did they do?
They had people solve logic problems inside an fMRI scanner. Some problems were abstract, like the number color task, and others were concrete, like the drinking age one.
And they saw differences in brain activity.
They did. When people were working on the abstract logic tasks, they saw more activity in the parietal lobe,
Which is involved in.
often associated with spatial reasoning, manipulating things mentally.
Okay. And for the concrete tasks,
For those, there was more activation in the left hemisphere temporal lobe,
which is more related to.
often linked to language processing, semantic memory, our knowledge about the world.
So different types of problems seem to activate different brain networks more strongly.
That's the implication. It suggests our brains really do process these two types of information somewhat differently, lending biological support to the dual process idea.
Fascinating. Okay, moving on slightly, you also mentioned another research method, think aloud protocols. How do those help us understand thinking?
Right. Think aloud protocols or verbal protocols. It's a method where you basically ask someone to narrate their thought process while they're solving a problem.
Just say everything that comes into their head.
Pretty much step by step. Okay, now I'm looking at this part. I'm thinking maybe I should try this. It's an attempt to capture the thinking process as it happens.
What's the value of that?
It can give researchers a really rich, detailed view of the actual strategies someone is using, where they get stuck, what assumptions they're making. It makes the internal process more visible.
You gave that letter number puzzle example.
Mhm.
D equals 5. What might someone actually say?
They might say, okay, D is 5. Let's find an equation with D. Ah, here, D plus E equals F, so 5 plus E equals F. E can't be 5 because letters are unique digits. Maybe E is small. Let me look at the last column first. T plus T equals R. Maybe there's a carryover involved. You get the idea. It's a stream of consciousness related to solving the puzzle.
Yeah, I can see how that would reveal their approach. And you had us think about a couple of questions related to this. First, how easy is it actually to think aloud while problem solving?
What do you think? Does it sound easy?
Honestly, it sounds kind of hard, like it would interrupt my actual thinking.
That's a very common experience. It takes extra mental effort to not only solve the problem, but also articulate the process simultaneously. It can slow you down, maybe even change how you think slightly.
Right, it's an extra task layered on top.
Exactly. It's not entirely natural for most people.
And the second question, would training people to do it be helpful for researchers?
It's a bit of a double-edged sword. Training could make participants better at verbalizing, giving researchers clearer, more detailed data.
Okay, that sounds good.
But the training itself might make the process less natural, more structured. It could potentially obscure some of that quick, intuitive System 1 stuff that researchers might be really interested in.
So it might make the data cleaner, but less representative of natural thought.
Potentially, yes. It's a trade-off researchers need to consider.
Okay, so we've covered a lot about this dual process model.
Yeah.
Like any model, it surely has its strengths and weaknesses. What are the main points in its favor?
Well, a big strength is the evidence we've talked about, the consistent results from behavioral tasks like the Wason task across different variations, and importantly, the biological evidence from fMRI suggesting distinct brain activity patterns.
So converging evidence from different angles.
Yes, and the model itself provides a pretty intuitive framework for understanding why we make certain kinds of errors or fall prey to cognitive biases. It gives us labels and explanations.
Okay. And on the flip side, what are some of the limitations or criticisms?
One criticism is that it might be a bit too simple, too reductionist. Is it really just two distinct systems, or is it more like a continuum? The exact interaction between the systems isn't fully mapped out.
How they influence each other isn't crystal clear.
Right. And the model doesn't always fully integrate the role of emotion, which we know is hugely important in decision-making. Also, the definitions can get a bit fuzzy, like, is all fast processing System 1? Experienced experts can perform complex tasks very quickly using what seems like System 2 reasoning, just highly practiced.
So expertise can make System 2 feel like System 1 sometimes.
Exactly. It blurs the lines a bit. So it's a powerful model, but maybe not the complete final picture of human thought.
Okay, that makes sense. It's a useful lens, but maybe not the only one. So let's try and wrap this up. What are the key takeaways from this deep dive?
I think the core idea is recognizing these two fundamental modes of thinking. System 1, the fast, intuitive, automatic pilot.
Prone to shortcuts and biases.
Right. And System 2, the slower, effortful, more analytical mode. We've seen how they have different characteristics, how System 1 often gets the first crack at things but can interfere with System 2.
And the Watson task really showed that conflict in action.
It did. And how context abstract versus concrete matters hugely. Plus, there's that biological evidence suggesting these aren't just abstract concepts, but have some basis in brain function. And finally, acknowledging it's a useful model, but like all models, it has limitations.
Okay, and bringing it back to the listener, why is understanding this valuable for, just living life?
I think it's about awareness, really. If you understand these two systems, you can start to notice them in your own thinking. You can ask yourself, okay, was that decision pure gut feeling, pure System 1? Should I maybe engage System 2 a bit more here?
So it helps you spot potential biases in your own thinking.
Exactly. Or recognize situations where maybe you should trust your intuition because it's based on solid experience versus situations where a quick judgment might be risky. Think about maybe a snap judgment you made about a person or an impulsive purchase.
Yeah.
Was that System 1? Could stepping back and using System 2 have led to a different, maybe better outcome? It gives you a tool for reflection.
That's a really practical application.
Yeah.
So here's something for you to mull over. Think about a decision you made recently. Could be big, could be small.
Anything. What you had for lunch, a work decision, how you reacted to some news.
Yeah. And try to identify which system felt more dominant. Was it mostly that quick, intuitive System 1? Or did you really engage in that slower, deliberate System 2 analysis?
And then ask yourself, what might have been different if the other system had played a bigger role? If you'd relied more on intuition or if you'd forced yourself to think it through more slowly.
It's about becoming a more conscious thinker, right? Using this framework not just to understand the theory, but to understand yourself. How could knowing this change how you approach the next challenge, the next choice you face?